Hi, everyone. Thanks for joining us today for our webinar, Ionic and Covalent Bonds, What's the Difference? I'll be passing it off to our presenters, Noose and Melissa, here in a moment, but just wanted to go over a few housekeeping items while people are joining us. We would love to answer all of your questions during the session today, so feel free to either use the chat or the Q&A feature on Zoom. We'll be monitoring both of those. If we happen to not get to your question, we will be following up with you afterwards. We are recording this webinar, so you'll receive a follow-up email with the webinar recording. I'll also be sharing a link to a shared folder that has some additional resources for you, and you'll also get that in a follow-up email along with a certificate of attendance. So with that, I will pass it off to Noose and Melissa.
Hi, my name is Noose and I'm a chemistry specialist at Vernier. And I came to Vernier about 5 years ago, and been using the equipment for almost as long as the company's been in business. Our 40th anniversary is this year, and been using the equipment since 1984. The company started in 1981. Taught chemistry and physics in Maryland for 34 years, and then came to Vernier after that. Melissa, you want to say something?
Yeah. Hi, everyone. Thanks for joining us today. As Noose said, I'm Melissa. I'm also one of the chemistry specialists at Vernier. There's three of us, Noose, myself, and Elaine Nam. And if you ever call or have chemistry questions, you're very likely to get one of us. Let's see. So I've been at Vernier for a little over 11 years now, and I joined Vernier after teaching at the college level for a couple of years. And if you have any questions, just like Angie said, please put them into chat or Q&A. I'm monitoring that as well, but chat is kind of what people prefer, so that's fine too. Also, just give us feedback. Let us know how the activities we're talking about are doing for you. And if you have any questions or comments or concerns, throw them into chat and we'll address them. I'll definitely stop Noose and make sure he addresses any questions or comments, because sometimes he'll just keep talking. So we have to stop him every once in a while.
Oh, I don't talk that much, do I, Melissa?
Not at all. Not at all.
Oh, yeah, she knows me better. But anyway, here, I'll share my screen and we'll get kind of cracking here. What happened was we talked about this over the summer, like we're going to do this series of chemistry webinars, and what are the topics that teachers do sort of at the beginning of their courses and try to hit those. And this is the last of that topic. You know, I taught, chemistry for a long time, and I taught, every level from 9th grade up through AP. And so, we had different webinars, and this one was certainly an important one as far as the concept is concerned. But how can you use Vernier technology to help your students understand this concept? So that was the thought behind doing this. There's by the way, you get access to all this stuff, including the slide deck. So just enjoy and watch along. All the links and stuff are in there. So you'll be able to get all this stuff. And so what we're going to do today is we're going to use the conductivity probe. I kind of think of it as a little bit of a redheaded stepchild, because a lot of people just don't really use it as much. And it's really a cool probe, and the Go Direct version actually has an even cooler addition besides the fact that it's wireless and so forth. So we'll look at that. We're going to share data remotely with you, which is a kind of a new feature, relatively new feature of our graphical analysis software. And we're also going to give you a code that'll allow you to play with it for a week, and you're welcome to try it with your students and so forth. And as was mentioned before, we'll look at expectations here in a second, but as was mentioned before, if you have a question, comment, concern, please just jump in. We don't have a huge number of folks today, so just jump in and let us know, how'd you do that, or where'd that come from, or whatever. I believe it's in the chat, and if you need it, let us know. There's a link to a folder of shared files. I always felt like, these webinars, I don't want to just watch, and I want something to do. And so we've got some experiment files in there. We've got some instructions for students. I mean, this is all for you. It's all free. Just help yourselves. If you can use any of it, please, by all means, do that. And so you have access to that. And then remote education has been a thing now for 18 months. And so we are former teachers, and we, none of us had to go through what you guys are going through, but what can we do to support teachers in the classroom, to help them with remote learning, especially in science? And so there's a lot of aspects to that. And what we're going to do is kind of model a little bit of that and answer questions. If you want to know anything at all, please, Melissa's watching the chat. Or if you want to unmute your mic and just yell at me, that's fine. A lot of parents yell at me, and so, but by all means, just let us know what you think. So electrolytes and non-electrolytes. If your students are, athletes, they might have heard those words, at least electrolytes. I was thinking about this morning when I'm getting ready, it's like I had a student that was a super tennis player, and he always talked about eating bananas, things like that. So, what are they? And then how does that relate to different types of compounds, ionically bonded compounds, covalently bonded compounds that form molecules, and then how can we characterize those? So we're going to, of course, do that using conductivity, write formulas for these compounds, and also write equations for the dissociation. And that's what we're going to be playing around with here. Have an hour or so. We won't go crazy, but we'll definitely talk about all this. And this is all in the experiment files that we shared with you. So if you look at the two experiments, 13 and 14, they all deal with this type of thing. And so what we're going to do is do a live demo. One thing that we're going to do is we're going to share my data with you eventually. So what we're going to do is, if we go back to, is it on that page? There we go. We're going to give you a copy of Graphical Analysis Pro. So if you already have Graphical Analysis on your device, preferably on maybe your phone or a Chromebook or an iPad or something, so you don't have to keep switching pages, what we'll do is we'll make it into Pro. So this is my copy of Graphical Analysis that is not Pro right now. And so what you need to do is, if you want a copy of Graphical Analysis Pro, launch it. And down at the bottom, pardon me, I said that if you want to copy it, you have the free version, launch it. And if it's free, it'll say activate additional features. And what Melissa will do is she'll pop that code into the chat. And then depending on the device you're on, you can either copy and paste it, or you can just type it into that box at the bottom of Graphical Analysis. And when you do that, let me see if I can get a copy, since for some reason Melissa she put the link to Graphical Analysis. So if you don't have it, it'll run on anything. If you don't want to give up your screen, to run Graphical Analysis, so you don't have to keep switching back and forth, just put it on your phone or, any other device you might have handy. And then pop that code into the box at the bottom, or type it in. If you're on the phone or iPad, you're probably going to have to type it in. And so what'll happen is, once you've done that, it'll make your copy of Graphical Analysis a Pro copy. It's only for a week, but you can still fiddle with it. You're welcome to share it with your students, the same code, you would do the exact same thing. We do offer a 30-day free preview, and it's on the link is on our website. So you can get a copy that'll last a whole month and try it out. The Pro version is not free. There's a free version, and you can do the experiment that I'm about to do. You can do with the free version. You don't need Pro, but I want to share some data with you guys later. And so that's why we're going to, I want to, hopefully let some of you see this and experience it. So anyway, let's do the experiment. Okay. So I'm going to go back to different set of screens here. I've got a camera set up. This is my little lab station here. And then I've got graphical analysis, of course. Let me get that on here. I'll move it off to the side so it's not blocking what you see. Two experiments that we're going to explore. One is electrolytes and non-electrolytes. What are they? How can you tell them apart? There's, I don't know how many of you might be of a little bit more seasoned era of the I don't know if you remember ChemCom. Many years ago, we built these little devices that we could use. Let me grab something that's super obvious, like here's some calcium chloride, right? And so that we built these things, and here I took the ChemCom one and put it on a paint stick just because it's a little easier to hold than the ChemCom one, if you know what I'm talking about. It was in a film canister, but the idea is if you close that contact with something that conducts electricity, then you'll hear that sound. And that LED is a flashing one. It don't have to be a flashing LED. You can have non-flashing LED. You get the idea. So, you could use this thing with ninth graders. I used to use this for conductors and insulators, right? But if you have a solution that's an electrolyte, then you can characterize that solution. Okay. And so, especially with my ninth graders, this was very, very easy to do. But the thing is, you can't quantify much with that. It's a little hard to look at weak electrolytes and things like that with this device. It'll tell you one or the other. Kind of fun to do is to also look at things like different kinds of water. But I'm going to put this out of the way. This thing, by the way, is in the free folder. So if you go to the shared folder, I put the instructions, DYI conductivity device. I put the instructions there, and you're welcome. Maybe you have a shop in the school. There's not much to it. A series circuit of an LED and a light bulb, and an LED and a battery. And if you want, you can add a beeper. I added the beeper. The ChemCom version didn't have a beeper, and I saw a workshop I don't know, 20 years ago, 15 years ago, and someone had added the beeper, and I thought, oh, the audio side, that's kind of cool. But anyway, let's quantify it, right? So I'm going to get these guys out of the way now. And so let's quantify that. And so if you look at that experiment, let me pull it up on the screen here so you know what I'm talking about. It's the first of the shared experiments there, number 13. Just the idea of what is an electrolyte and a non-electrolyte, right? Just that, and how do you quantify the difference? So, because you can also talk about weak electrolytes, right? And so you go through here, and what the students are going to be expected to do is think about in solution what's going on, right? So you've got these ionic compounds, these molecular compounds. Honestly, folks, I did not teach molecular acids at this point. Okay, because that enters a whole realm of confusion. I wanted the students to see the difference between these molecular compounds and ionic compounds. And honestly, the main thing I wanted them to see was the fact that there were metals in the ionic compounds and there were no metals in the molecular ones. When you get to these molecular acids, then there's this whole confusion of hydrogen and hydronium, and I didn't teach it at this point, but you can, okay? And I have it set up so that we can look at that, and then they can write the equations for this, and that was very important to me, that the students understand how to write good equations. Okay, so there's all these instructions, pretty straightforward. What I did was I gave the students, let me put it up on the screen. This was my own concoction, and that was a data table to record this. So let me bring here's the data table, and you're welcome to a copy of it. And this is a Google Doc. It's very editable. Take it, do what you want. I did have, the day before, I did do a thing with a piece of aluminum foil. I made a little boat out of it, had the students just hang it over a flame. I started out with a candle flame, and they would try to melt sugar and salt. And they would discover that, the candle flame would melt the sugar, but not the salt. And so the idea of a high and low melting, right? But then when you get to this experiment, let's test some substances, and let's get some quantifiable data, right? So I gave them a data table, and they would record their data, their data in the table, and so that's what this is all about. So let me show you how it works. Now, I am going to do something a little different than I would have done with students, and that is I'm going to put the probe into the samples. I'll need to make sure that I rinse it really well in between. With my students, I used a ton of disposable bathroom cups, right? That was the easiest way to make sure they weren't cross-contaminating and having some weird, things happening. But for the purpose of the workshop, I made these bottles with nice big labels so you guys would see what I'm doing. So, but I would never have the students put the sensor in the bottle. That the chance for contamination is huge. I've got the sensor connected. Let me tap on sensor data collection. I wanted to show you another feature of our GoDirects. This is kind of a side thing, but it's kind of neat. Our GoDirect sensors, this one is connected. It's right here. It's connected by Bluetooth to my computer right now. This thing will connect to anything. It'll connect to a computer, Chromebook, to a phone, to a tablet, by Bluetooth. If your device has a USB cable, we supply it with a micro USB cable that so if you have a USB port, I should say, that you could plug it straight in. The cable also serves to charge the sensor. If you're going to use it by Bluetooth, you got to charge the battery. But this is connected. And I wanted to show you, before I get too far down the road here, that a lot of our sensors serve double purposes. This sensor does, of course, have a conductivity channel, but it also has a temperature channel. And so these are temperature compensated. Unless you don't want to, you can turn the compensation off. But you can also read the temperature right out of the sensor if you want to. For what we're doing today, that's not appropriate. But if you taught, like an environmental science class or biology class, maybe that might be something that you'd want to do, is turn that channel on. So anyway, let's do the experiment. Now, I'm going to, all of our sensors, well, most of our sensors, I would say almost all of them, when you turn them on for the first time and you connect them, the software will recognize them and set up a time base. But let's go back to the experiment. We are going to measure the conductivity of a whole bunch of things. And we just need to know the conductivity of the solution. We don't need it against time. I mean, that would be overkill. We guess we could do it that way, but that would be way more than we need. Wouldn't it be nice? I like to ask rhetorical questions. Wouldn't it be nice if we could have the software record the data and keep track of it for us, but not time-based? And so, bottom left corner in graphical analysis, there's a thing called mode. I'm going to make the screen ever so slightly larger so you guys can see what I'm doing better. And I'm going to change the mode from time-based to event-based. Event meaning it's just going to record data for a specific event. And that event's going to be called sample. There's two event options. There's one called selected events, and there's one that's called events with entry. The entry value would be, you would have to put in like what the thing is, and in this case you can't enter words, so it would have to be a number. The other option is a little faster. If you do selected events, then what it does is it assigns a number to that data point. You'll see it here in just a second. The other thing to consider, if I was talking to a colleague recently, and they were doing this with soda, and sports drinks and soda, and what they discovered was the values were jumping around a little bit. So you could turn on the averaging option. If the values are jumping up and down, it'll take readings and average them over 10 seconds. I'll turn it on for the kicks right now, but it's not going to change too much for us, but it might. So we'll see what happens. So I'll start this. And then the neat thing about this mode of data collection is that there is no urgency. You can start collecting, and it doesn't actually collect a point until you're ready. Now, the students can do the experiment in any order they want, but they need to keep track. And that's why you need the data table, right? So you've got this data table, and you'll see on here sample number in GA. They're going to need to record that, right? If they're taking the data, they need to write down, oh, that was number 1. Oh, that was number 2. So, I'll do them in this order, but there's no particular need to do it in this order. Just keep track of the sample number, right? So right here, since it's just me, I'll do sugar for number 1. So let's get a sugar solution here. I have sucrose. Now, here's the other thing. I changed this. So when Vernier supplies lab files, you get them 2 ways. You get them as PDFs, which is what we gave to you, but you also get them in Word. And what I did was I changed the labels so that they're all words. Why? I want the kids to work out the formulas. Work out the formula for sucrose, work out the formula for sodium chloride. That is instructive in itself. So on that data table, you will notice that there is a column for the chemical formula. Okay, have the students work out the chemical formulas for all these things. Some of them, mineral oils, a little challenging because there's lots of different formulas for mineral oil, but most everything else you can come up with something. So let me take the sucrose solution and let's get a conductivity for it. Okay, so like I said, I would never have my students put the probe right into the sample, but for our purposes today, just to speed things up, I am going to do it because everything is labeled and you'll see what I'm doing. I would have them put it into a bathroom cup or a test tube or something like that, so that there's less chance that they're going to contaminate the stock bottle. But all right, let's get a reading here. Oops, I guess I might have to take it out. Well, one of the issue with this sensor is that it's barely reaching. You want that graphite electrode to completely enter the solution. So it looks like my plan there has been a little bit modified. So let's get a sample of sucrose solution. Notice the graphical analysis doesn't care, right? It's just waiting. Yeah. So let's see if I completely covered. There we go. So I have completely covered it. Let's make sure there's no bubbles in there. And so then, swish it around a bit. There's this meter at the bottom is live. You can make a bigger meter by tapping on the view options. You get a little bit larger meter. When you're kind of happy with that value, it's not jumping around too bad, tap on keep. You might remember that I told it to average. I don't know that we're going to see too much of an issue with this data that I'm collecting, but like I said, a friend was doing soda and it was jumping around a little bit. And so what they did is they used the averaging value. I can turn this red thing off here. And so that's something to be aware of, that you have that. And so there's a conductivity of the sucrose solution. All of these in the experiment file are all 0.05 molar, just so that is not an issue. Depending on the level of the students, you could give them sugar and have them a pinch of sugar dissolved in water. Lower level student, that may not be too much of a discussion as to keeping it the same concentration. But in this case, we wanted to keep the concentrations constant. All right, so we just did sucrose. So what the students would do is they would say, okay, this is sample number 1, and so they're going to need to go in the data table, and they're going to have to record that, right? They need to keep track of that in some way. Okay, let's go back and do something different. So let's just jump. I mean, does it matter what order we do them in? No. Here is just, we did sucrose. Let's do table salt. Once again, work out the formula, right? Have the students work out the formula. That to me, when they see that in there, one of the questions that I always asked was, make a table of the high conducting and the low conducting, and then compare the formulas. And of course, they're going to see that the high conducting, I was a little bit too conservative there. Let me give it a little more. The high conducting solutions, are typically, are going to typically have metals in the formulas, and the low conducting solutions are not. And so look at that. Okay, here's one that is jumping around a little bit. You might give it a little swish, then stop fiddling with it. Okay, and then once it looks like it's kind of stabilizing, this might be a good one for the 10-second average. I'll tap on keep and let it do its thing here for 10 seconds. So it's reading all the readings and it'll throw an average value in the table. Okay, let's do a couple more, and then we'll go to the other half of the demonstration. And so let's do, what about water? Now, that's an interesting discussion all by itself. I volunteer at a local science museum here in Portland. It's called OMSI. If you've ever been to Portland, it's a great place to go. And they have a chemistry lab. And we have gotten questions about, from people about water. When I was in the classroom, kids would ask me about what's the difference between different kinds of water. So, I've got some spring water, and I've got some tap water. For this particular experiment, you might just use distilled water just because you don't want anything else, the whole idea of, well, is it a contaminant, right? But the whole idea of those other ones, is they're going to have ions in there. But, straight up distilled water shouldn't be a huge conductivity, but let's find out. Okay, so that's my distilled water there. Oh, I wonder if my test tube wasn't clean. That's pretty high conductivity for what I thought was distilled water. So I don't know if if my test tube wasn't clean or what. So it's definitely lower than the salt, but much higher than I expected. So it might be interesting with this experiment. That I wonder if that'll beep. With this experiment, we had a still at our school, but it wasn't a very good one. And we did buy distilled water from the grocery store because we typically would get some kind of contamination in our distilled water, and it wasn't quite showing what we were hoping to show. So, that one right there is giving me a little bit of concern, just because, like, what is that actually? This is isopropyl alcohol. Okay, so let me clean, since my probe definitely was reading some conductivity there. So I wonder how clean that test tube was. All right, so if I don't trust the test tube, I guess I should rinse it, right? Well, let's rinse that. I don't know, I'm trusting this distilled water. Okay, more than I'm trusting the test tube. So let's see. All right, a little bit of isopropyl. Okay. The original version of this experiment just had the students read the meter. And I really like the idea of having a record kept from the software. By using the selected events mode, look at that. That's kind of what I was expecting for the water. By using the selected events mode, you get it to keep a record of what's happening. And so, you could go through any number. I mean, that table has a lot of stuff in it that I shared with you. Don't feel like you have to do all that. Eliminate some of it. Kind of depends on the class, how much time you have in your class and so forth. But the neat thing is we're seeing some differences here, particularly between I'm a little disappointed with my distilled water pardon me, but particularly between the molecular and ionic compounds. And so one of the questions you would have that the students do is look at those formulas and compare them to the conductivities. And what your students will find is that those compounds with metals in them are typically going to have much higher conductivities. Let's do one more of that group, right? We did sucrose and so let's do, I think I have aluminum chloride hiding here somewhere. Here we go. So here's some aluminum chloride. You could do, any ionic compound. You want to do some copper sulfate, or you want to do some sodium carbonate, or all kinds of things like that. I am rinsing my test tube. I'm just curious now. Now I've got this curiosity going. It's like, dang, was that test tube really bad, or is my distilled water bad? I think it's the test tube, because when I did the you would assume that if the water was bad, and I rinsed, I don't know. Let's find out. This one has just distilled water in it right now. Definitely lower. So I'm guessing I definitely had a contamination issue there. All right, that's distilled water. Let's put aluminum chloride in test tube number 5. And let's get a reading on the aluminum chloride. Yeah. There we go. Oh, look at that. Okay, so give it a little swish.
I will also say with these conductivity probes, and you already mentioned it, but we're talking a lot about contamination and being really careful with your readings. the way all our conductivity probes are, that graphite electrode's kind of recessed in that plastic. So you really need to get in there, have your students get in there with the water bottle, wash it off, make sure they get, because you could have little droplets that get stuck in there from these different solutions. And yeah, exactly like that. See, you could just have little droplets kind of that sit in there, and it's really good to just get the whole water bottle if you want it. Sometimes students get a little overzealous and try and put a paper towel in there and everything. That's not really necessary, but just squirting it with the water bottle is really helpful. And I will also say this selected events mode, I know chemistry doesn't use it a whole lot, but it helps with this too, this averaging and actually getting a record of the data. So I love that Noose has modified this experiment for selected events mode, because we really don't use it enough, and it's a great mode to have in your back pocket.
I'm glad you verified that, Melissa. I feel better. I was feeling guilty that I modified Don's experiment.
Never feel guilty for that. New technology, we need to embrace it.
Yes, absolutely. Yeah, and you can, if I'm going to slide the camera, well, I don't need to, you can see it. I've got some sports drinks back here. I mean, electrolytes, sports drinks. You might have your students test, what is all that stuff that they use, the muscle stuff, and I don't know, the stuff they drink, but then also, smart water, what makes water smart? And so, there's so many things, and this probe is just marvelous because it's so sensitive, and as you saw, you'll notice big differences. So now I'm going to move on to the second experiment. We have about a half an hour left, and that one actually does take a little more effort, and it's a little more what's the thought? Okay, I'm not coming up with a good thought, but I will as I go along. If you wanted a copy of this data right now, I could share it with you. And so, well, let's just do that, just in case somebody wants a copy and wants to keep this, so you have something to look at later. And so the way you would do that, let me bring my my iPad. I'm going to bring my iPad up here, and that's to represent you. Okay, that what I want you to do, if you want my data, okay, is tap on data sharing on your copy of graphical analysis. If you've made your graphical analysis pro, like we talked about earlier, just tap on data sharing and wait. Okay, you'll get a screen that looks like that. Okay, and what it says is it's waiting for a source for the data. I'm representing the teacher, so I'm representing you in front of your class. And up here on the top right corner of my copy of graphical analysis is a little thing that looks like a Star Wars TIE fighter. And I'm going to tap on that. Okay, and I'm going to start a sharing session with you. So when I start the session, it generates this code. Now, we specifically asked our software guys to make this as easy to type in on an iPad or a tablet or a phone. So the small case letter N, let's see, I got to type it on mine too. Small case letter N, small case O, small case B. Melissa, I'm pretty sure that capital O is actually a 0, right?
Yeah, I think that's a 0.
I think so. I think
I'm checking it right now, but it's a 0.
I think we told them that because we didn't want that confusion of like a capital O versus a small o. Did I type O? I typed 9. Dang it. All right, so 0. I boogered it up bad here. NOB 0, and then okay, and then OM. Try to make it so that, particularly when you're on a portable device, that it, the data, the codes are not too complicated, too long. But if you notice my iPad, and in your case, it should have happened too, is you just got the data. right? I don't know where you are in the world, but we're in Portland, Oregon, and I just sent you the data. So if you tap on the little square, this is my iPad now. If I tap on the little square of squares up here, the view options, I can turn on the data table and look, there is the data. Maybe if I can tap somewhere else so I don't have to show that. Come on, baby. It's interesting. It wouldn't let me show it to you, but you'll get it. I mean, if you tap, usually if you tap somewhere else, but for some reason it's not allowing me to do it. But that you will have the data behind there. It's interesting that I can't actually do that. Weird. Did I find a bug, Melissa? Maybe.
It's working for me, so I think it might be your iPad.
So it's my iPad or my dry fingers. I'll almost guarantee you. Yeah, folks, if you want this data, save it. Tap on the top left where it says there's a little picture of a file and save the data. So if you'd like a copy of this for the future, tap on save and save the data to your device or the cloud or whatever works for you. I'm going to get this iPad out of the way because it's embarrassing me. Okay, so and Melissa put the code in the chat, so if you need it later, because I am going to change the experiment right now because we have another thing to look at. Let's compare ionic compounds. So I have 3 solutions made up. Now this is 1 molar sodium chloride. This is 1 molar calcium chloride. Maybe if I don't drop it all over my house. Here we go. And 1 molar aluminum chloride. What we're going to do this time is a slightly different experiment. We're going to compare the way those solutions conduct, but in kind of a more quantitative and analyzable way. It's not just going to be looking at the conductivity. We're also going to look at a graph as we increase the concentration of each one. So I'm going to take a little beaker and I'm going to put 50 milliliters of water, distilled water in there. I think my distilled water is better than I thought. Hopefully I cleaned that beaker well enough. You got to be careful that when you lower the probe in there, this, you could do this without a stir, but it is really handy if you do have a stir. Want to make sure I've got enough water in there to cover the end of the probe. Yes, I do. Turn my stir on. Try not to beat up the probe too bad. There we go. What's the conduct? Oh, nice low conductivity. All right, I'm going to start a new experiment. On your end, you're going to see something wacky come up. So I'm going to do a new experiment, and if you haven't saved it yet and you want to save it, this would perfect time. But if not, I'm not going to save it because I'm not as proud of that data. That distilled water was kind of weird. You're going to get a little prompt that says, do you want to join this new experiment? Okay, and if you want to, you'll get the data live this time. But what I'm going to do is I'm going to put the drops of the solutions into this beaker and collect the data for each drop. And the lab calls for 10 drops, but I'm going to just do 5 because we're running short on time and I want to do all of them so that we can compare them and look at some features and graphical analysis. So, and I don't want time. This time I want to use events-based again. So bottom left corner, I'm going to change the mode to events-based, but this time I am going to put in the value. And, if you're real careful and you pay attention to what you're doing, it'll do 1 drop at a time automatically. I'm going to do volume in drops. This is all in the experiment file that we shared with you. And I'm going to drop 1 drop at a time. And so, but I'm going to use events with entry. Maybe my hands stutters and I end up putting 2 drops in instead of 1. So anyway, here we go. And let me get the meters at the bottom. Let's see if I can. You don't need to see all that junk there. This will look a little better, I think, if I turn on a meter. So, all right, let's see. I'll slide this down. A lot of things you can adjust in graphical analysis, which is kind of neat. So start collecting data. Events mode, no rush, right? Have I put any drops in? No. So I'm going to tap keep, and it's going to say, how many drops did you put in? I didn't put any in. Not yet. 0. Look at that conductivity. All right, let's start with sodium chloride. Okay, put the other 2 away so I don't mix them up. Let's put a drop of sodium chloride. These little dropper bottles are great for experiments like this. I'm going to try to put in just 1 drop. Wing it up really good. Let that conductivity reach a a stable value. Give it a little more spin action here. Looks pretty good. Tap keep, and maybe tap keep, and I put in a drop. Okay, let's put in another. I'm going to put in another drop. Now the total number of drops will be 2. Okay, so I just put in another drop. Notice the conductivity. So wait till it stops changing. You should be getting the data, by the way. If you're pro'd up, you should be seeing this appear. It's not as exciting as time-based data. Melissa and I were talking about this earlier today. Time-based data is great, because it comes through real time. This one, events-based data, not so exciting, but this one's not bad because it doesn't take too long. Let's see, that was my 4th drop, wasn't it? Yeah, I think it was. Let me cancel that. I'm going to triple check the data table. Oh, I put in 2 drops already, so that was my 3rd drop. So let's keep that. In the Vernier world, if you enter data, you can change it. But if a probe collects the data, you cannot. So you can only change data that you enter. So if you make a mistake, if I had put in the wrong value, I could have easily fixed that. But you cannot change data collected by a probe. Okay, and that's kind of to discourage students from kind of adjusting data to fit what they think it should be the result, right? So, all right, I'm gonna do this last 5th drop, and I'm gonna stop just because of time. I want to do all of them, and I want to show you something cool. And usually you do 10, but you guys will get the point. Look how linear that thing is. So there's the 5th drop. So I'm going to stop collecting data at this point. By the way, if you stop collecting data and you go, oh, no, I need to collect more data, just start collecting data and append to the set. So there's no penalty for stopping or anything like that. What you don't want to do is, if you want to add to the existing data set, don't create a new one. That'll get things all excited. But anyway, let's see, where are we? Let's stop because I had started collecting data. Did I lose the data point? Yeah, it's the first one here. Okay. So let's look at that, and we can do, you should have this if you are pro'd up with me. You can do a curve fit, tap on the little graph tools here, do a curve fit, very linear, look at that slope. We'll deal with that slope in a minute. Okay, we're going to look at that slope once we have another set of data to look at. Now, with graphical analysis, when you want to collect
some really pretty data, Noose, by the way.
Should I have done 10 points now?
That's really pretty. That's got a really good correlation. That's really pretty.
Yeah. Sometimes I feel bad because I've told this to Melissa and Elaine before. Like, I'll do these things as demos, and people are like, "You cheated!" Like, no, I honestly did not. And I get this really good data, and folks I feel bad because, like, maybe I should get worse data or something. Anyway, I clean the probe. Let's clean the water. Let's clean the beaker here. And so I'm going to get my larger waste bottle. I always use these real expensive waste containers. 2-liter bottles in my classroom were like a standard. Yeah, I use them like crazy in my classroom because they're just great for large beakers and waste containers. I taught 9th graders, and we'd make bio bottles out of them. All right, hopefully that's pretty clean. Let's put some water in there. Once again, it's not super critical how much water you put in here, but it is important that you be consistent, and you also cover the bottom of the sensor. That's kind of the most important thing. Let me clean the magnet. Hopefully my conductivity here for 0 points should be real close to what it was before. Okay, yeah, look at that. It's pretty good. All right, so I'm going to start collecting data again. Neat thing about graphical analysis is that it auto saves. So if I start collecting a data, it actually created a new data file for this. It's showing this one because I selected it, but I can turn that off and turn on the new one. Here's the new one. And so let's see, let's keep 0 drops. And this time, let's do calcium chloride. So I'll set the sodium chloride aside. Let's do calcium chloride. Put a drop in there. Okay, let's see if I can impress Melissa again. 1 drop. Get a little spin action going. Watch that conductivity. You want to wait till it kind of stabilizes and then grab that point. So I have 1 drop in. Ooh, don't think it did it because I didn't type anything in. So there we go. All right, so let's do another drop, which will be, of course, be 2 drops. A little flinch thing going on there. All right, folks, if you have any questions, comments, concerns, what the heck are you doing? Please let us know. 429, keep. I really want you to see the slopes and think about what the slopes mean. Remember, I started with sodium chloride, so I've got a Van Hoff factor of pretty close to 2. And now I'm doing calcium chloride, which is a Van Hoff factor. So I did 2 drops, so this is drop number 3 of 3. Sorry, the 3 coincident. And then we'll do the aluminum chloride. And so let's get that conductivity to level out there. That looks pretty good. And that's my 4th drop. 1 more drop. Yeah, titration by Data Pro or Graphical Analysis Pro is super boring. This one's not so bad. Like I said, time-based ones are ideal. All right, so that's my 5th drop. All right, so I'm going to stop data collection. Now let's look at the 2 lines together. So I'm going to turn on run 1 and run 2, and I'm going to do the same thing I did before. I'm going to fit a curve, a linear curve to both lines at the same time. Okay, and want you to look at those slopes, 143, 226. Now think about that. Half of 143 is about 70 something. So what if we did the ratio of the slopes? How would that compare to the Van Hoff factor being, the number of particles in solution? Let's squeeze in aluminum chloride and then we'll label everything and we'll call it good. Okay, so I'm going to turn that off. Let me do a quick clean here. And we'll get that last data point in. Where'd my magnet run off to? All right, dump that. Is there room? Oh, there is room in there. Okay, all right. I am definitely running low on distilled water, but that's okay. We're running towards the end of the workshop, so it should be all right. Let me rinse everything, put the probe under here, rinse the heck out of the probe. And then the probe's pretty rinsed. Let's rinse the rest of the beaker. I thought I had my red waste container was pretty full, but it looks like it's not so bad. All right, 60 milliliters of water. Whoa, just enough. I'm really running low on my distilled water, but I think I'm gonna make it. All right, let me get my magnet. Yeah, look at that conductivity. It's pretty consistent. So at least I'm cleaning things not too badly. All right, get that spinning. And let's get another data set. So start collecting data. I'm going to create a new one this time. And so this one's going to be for aluminum chloride. Let's keep 0. And let's find my little bottle of aluminum chloride. There it is. Okay, let's get that in there. We'll do 1 drop. My magnet is bumping into the probe there a little bit. So, all right, let's grab that point. It must be the bottom of the beaker because it's not touching the probe. I think that was 2 drops. There was a little bit of flinch action there, so hopefully that data point won't be too bad. Won't be bad if it is, because I can show you how to delete a data point if you need to. We'll see how linear the plot comes out. We're working on some updated features to graphical analysis, and one of the ones that we've all been wanting is to be able to strike through a data point, so that if you mess up, you can, rather than just deleting it, you can strike through it. So 1, 2, 3, this is number 4. Hope you guys are getting this, because that is really kind of a neat feature of GA Pro, is that, you know, I have a friend who teaches AP Chem in New Jersey, and back when they were doing hybrid, he had kids at school titrating and sharing their data live with their lab partners at home. He dreaded it. Steve was like, do I have to do every lab twice because kids are at school and kids are at home? With Vernier labs, the students were actually able to share their data live with their lab partners, and so it really kind of worked out well in terms of you know, that aspect of it, because they could you know, they could see the data, you know, as it was coming in. They were allowed in their school, they were allowed to have their phones. So, and that's so excited by that last slope. I don't know if I rushed something because we have.
I'm having trouble keeping track of which line is what. Is there something I can do to
Yeah.
note them?
I love having the plot in the audience there. I apologize for the aluminum chloride. I'm a little bit sad because the slopes are almost the same. But here's the deal. Open if it's not open already, open your data table. I don't need this meter anymore, so I'm going to turn that off. It'll be a little more screen space. Right next to where it says data set 1, there's 3 little dots. Tap on that, and then tap on rename data set. And so that first one was sodium chloride. Oops, that's really ugly. Let's get rid of that. Sodium chloride. Okay. And then we can do the same thing for the others. We'll rename this one. That was calcium chloride. And supposedly this last one was aluminum chloride, but I'm wondering if that bottle was mislabeled, because if you look at the slope, it's almost identical to calcium chloride, but we'll go with our data. Okay, we'll have to write an error analysis at the end. Hey, Noose, it would also be nice if we could see this on the graph. Bottom left corner, the little graph tools icon, turn on the graph legend, and then you can see the legend that lines up. And you know, 2 of those are kind of blue, 1 is green. Wouldn't it be nice if we could change the color? Tap on the y-axis label, the conductivity. If you tap on the little icon for the data point, like here, this aluminum one, I'll tap there and I'll make that one red. Okay, and so you can definitely adjust all of that stuff. Students can, you know, create a title on the graph. My students would lose a point if they didn't have, you know, a title, conductivity of ionic salts, or conductivity versus volume, or, you know, something like that. Okay.
Noose,
Yes.
we had a good question in the chat, since you discussed maybe the issue with your aluminum chloride solution there. What would you expect that slope to be? How would you expect the slopes to come out for these 3 different compounds?
I would expected the slope for this one to be almost 300. Okay, and the reason is that the ratio of these, like this one to this one, the ratio is about 1.5 to 1. And I would expect the ratio of this last one to the first one to be almost 3 to 1. Okay, and so yeah, the fact that they're both identical actually suggests to me that this bottle of aluminum chloride is mislabeled. But good question. Yeah, the Van Hoff factor. So you've got sodium chloride that's got 2 particles, calcium chloride that's got 3 particles in solution, and aluminum chloride that's got 4 particles in solution. So you'll get a reproducible. And by the way, I did put a sample data file in the folder that we shared with you that does come out that way, so that you can look at the ratios of the slopes. And it's your call when your classroom, do you want to deal with that or not? But honestly, it's there is some kind of a relationship that you can tie to the formula of the compound. And if you may or may not teach Van Hoff factor, I didn't. I would just look at the particles in solution, but that's the official term because there's more to it than just the particles. But at a first level, if I'm teaching this class to a Chem 1 group, I just want them to understand, what does it look like when I write a dissociation equation for each of these ionic salts, and then how is that affecting the number of particles in solution and the molarity of, if you're talking about molarity of particles in solution or the molarity of the individual, what happened. I'm starting with supposedly a 1 molar aluminum chloride solution. What's the concentration of the chloride? Okay, well, we would teach that it's 3 molar. Why? Well, we would have to look at the dissociation equation for that and say, oh, for every 1 aluminum chloride, we get 3 chlorines. So, that kind of thing, and you'll find that it's somewhat related to the slopes. So it's kind of neat to be able to do that. So let me show you a couple other things. Melissa and I and Elaine are available to you guys at any time. Any experiment that you want to do that's related to our stuff, we'd be so happy to help you with it. But like I said, in this shared folder, there's a number of things that you're welcome to use in your classes. This code that we gave you is good for a week. If you'd like to try that with your students, you're welcome to do it. Students can be the teacher. You can share data from your podium or whatever your demo table. There's a couple of other things we wanted you to be aware of, and they're in the presentation. What's going on with GA Pro. There's a couple neat things in GA Pro that you may find useful, and so you can explore that. If you like, I'm going to disconnect from you right now. Let me do that. Okay, so I clicked on the TIE Fighter. I'm going to stop sharing. That way, if you do want to save this data, even with that crappy one that I did, I'm not going to mess you up right now. I'm going to start a new file. And I want you to take a look at there's an item on the right here that says see experiments. If you have the free version of graphical analysis, this will basically tell you need to make your graphical analysis pro. But you guys have this. So if you tap on see experiments, a number of experiments from our lab manuals are included, but more than that, right? So if we look at one of these, like here's conducting solutions, okay? Yeah, this is a biology one, but it's kind of similar. You can also filter by topic. So you can look at just the chemistry ones if you want. And so there's different experiments here that we have built in. Here's one that's kind of nice because it's time-based. Let's look at this rate law one that Melissa put in here. Beautiful experiment. This is crystal violet. And so there's real data, but Melissa made a nice movie. You get to see the hand model there. She's using a GoDirect sensor, but of course, all of this stuff that we did could be done with a wired sensor. It could be done with LabQuest. You don't have to do it on. But what's neat about this is it helps students to see how the experiment was conducted. And so that's built into Pro. Added I don't know if it's value, but added to this is also the ability to link the data to the video. So what you can do is you can synchronize the data to the video. So you'll see that if at 52 seconds, the data, now in order to see that, I have to play it from up here. So it's got to, let me get a little further along here. Oops, I missed it. I probably shouldn't have fiddled with it. Let me pause and start. And so what happens is that this video, and Melissa, the parts that were no data being collected, she kind of sped them up a little bit. But when it reaches that 52 seconds point, it will start showing the data that's being collected simultaneously. So you can sync the data with videos, and you can do this yourself, or you can use our data. So at that point, what's happening is the data should be showing, but I think I boogered it up when I was fiddling around with it. And so the data, the data will be there, and you can synchronize it. Now in the test tubes, the kids can see what's going on that's happening inside the colorimeter. So I think I boogered this one up. Oh, there it is, but it's off by a little bit. Okay. Not only can you look at the ones that we give you. So if you start a new file and you just look at on the right where it says experiments, you can also do this yourself. So if you collect your data and you create I did this wrong. If you collect your data and you then going to grab some data here real quick, and then create a video, what you can do is you can then insert a video. So your students could collect data and take a video with their phone and then import that video into graphical analysis. So this is also a pro feature. This is not a free feature, but it is kind of a neat option that's built into graphical analysis. There are others, and we put it into the presentation. Melissa made this great chart that compares free to pro. If you own Vernier lab manuals, then you can do all the experiments in our Vernier lab manuals with the free version. The pro version is not required, but it does have some pretty cool additional features that you might want to look at, particularly now that you have it for free for a week. We're running out of time. Last few seconds here. I see there's still a few people in the group. Anybody have any last few seconds questions that have to be answered before we log off? If not, okay, you can contact us at chemistry@vernier.com. It's the three of us, Melissa, Elaine, and I. You can call and you would be routed to us if it's a chemistry related question. We're here to help you. If there's anything that we can do to help, let us know. We are still talking about spring webinars. We haven't quite set the dates and the calendar yet, but we will likely have something going on in the spring as well. Okay. I want to thank you for attending, and look, if you need the video, if you know any colleagues that need the video, you should be getting a link for that probably in the next few days. Okay. Have a good day, folks. Bye-bye.